Cool, so this is my pilot test for the practical element of my dissertation. As you've probably read already, I found or discovered a problem within monitor mixing, which has been identified by many professional monitor engineers of static performances. So this solution has basically been designed so the musicians monitor mix, their key instrument or vocal will follow them as they move around the stage. The basic idea is that the musicians get tracked with TI Max trackers and sensors from a company called Outboard in Cambridge. The musician wears the tags. This sends out ultra-wideband radar pulses which get picked up by the sensors around the stage. The sensors are connected via Cat5, coming back to an Ethernet switch, and then this comes back to a PC which runs the location engine software. I'm then going to extract these coordinates and put it into my computer, which is running Max MSP, which is basically going to be the main control surface. An object in nodes in Max will then basically control the level to the auxes on the Yamaha O2R. So it gives each wedge a level, translates that into, or from a value from 0 to 127, which is obviously MIDI values. And then via MIDI connection that then moves the auxiliaries on the desk. The desk is then sending out whether it's auxiliary sends to different wedges. So the idea being that as the musician moves across the stage, their monitor mix will move with them. For this pilot test, we're not going to be using outboards, trackers and sensors, mainly because of cost reasons. They're very expensive to hire, and secondly, this test is designed to test out basically the whole system apart from the outboard, so just test out the rest of the system. Firstly, I'm going to run through each section by section, starting with the Max patch, and show you how it works, how it's connected and how it all runs. Then I will demonstrate two tests on the system to show the actual movement in the monitors. I've also set up some microphones to record the movement, so it will be possible to hear rather than just through the camera speaker. Okay, so let's get started with showing you Max. Okay, so here is our Max patch, Max MSP, which is basically the main control surface for this system. Over here we can see it says Musician 1 Nodes patch. This is the Nodes patch for Musician 1. Each musician has their own patch, and we're just going to be using the one patch for today. Underneath we've got node number, we're currently selected to 4. This is basically the number of wedges that are going to be on stage. If we look at these circular objects down here on the stage plan, 1, 2, 3 and 4, these are the nodes or wedges that you can select from here. So we can move this number box here and adjust the amount of nodes or wedges on the stage plan. Now below this we've got our X and Y coordinates. So for the final test, or the real test, this will be fed from the TI Max trackers and sensors. So the coordinates that I'm going to be extracting will be adjusting these X and Y in real time. So as the musician moves around the stage, these X and Y coordinates will be moving in relation to where they are. For today though, for the pilot test, as I do not have the outboard trackers and sensors, we're going to be using this Metro and counter that I've made here, which if we turn on, you can see is moving the cursor here and adjusting the X coordinate. So this is basically mimicking how it will look when using the trackers and sensors. So this cursor is basically the musician. As he's moving, he's crossing over the path of the monitor wedges. Okay, if we come down to this section here, which is the interpolated weight of each node or wedge, you can see as it crosses the nodes, it gives off a level. So as we cross 1, full, 2, coming up to full, then 3, and now 4. Now we want to unpack these results into their individual monitors. So we've got an unpack object here, which is basically separating them into their individual. And then it comes into a scale object from 0 to 127. We have to do that so it conforms to the MIDI values 0 fully off and 127 fully on, so it can communicate with the auxes on the digital desk. So as we see, just about to come up over number 2, that will then scale to 127. As you can see, this number box here is then moving from a number from 0 to 127. And we've got aux 1, aux 2, aux 3 and aux 4. These values that are then being generated from 0 to 127 will come down to this control out. This is basically transmitting these MIDI controller messages to my MIDI interface and then into my digital desk. I can click on the control out object like this, and I'll be able to select which MIDI port I wish to send out of. Currently we're using MT4 port 1. Now the only other changeable message boxes here are these two here. The first one is the MIDI control change number, and the second one here is the MIDI control channel. So as you can see, for all 4 nodes or wedges, we are using MIDI channel 1, sending on MIDI channel 1, and each node or each wedge has its own control change number, as we want to be controlling obviously different auxiliaries on the desk. So we've got control change number 1, 2, 3 and 4. This section over here on the right we can ignore, as this is just the coordinates when you move your mouse around the stage plan. So that's the max patch. Now we can have a look at how this connects with the digital desk. So here's the PC running the max patch, and the connection from max to the desk is a simple MIDI interface. So it's just USB coming from the PC into this MT4 MIDI interface, and if we walk around the back of the Yamaha O2R, that simply goes into MIDI in. So when we come to the Yamaha desk, if we go to the MIDI in display access, it will come up with the MIDI controls and the control change and parameter settings. So as you can see here, hopefully on control change number 1, which is basically node 1 or wedge 1, the parameter is fader. We then got aux 1 send input 1, which means it's controlling the aux 1 on channel 1. And then control change 2 is for aux send 2, control change 3 is for aux send 3, and control change 4 has been set up to control auxiliary send 4, all on channel 1. So if we then come down here and hit display on aux select, we can now see the auxiliary sends. So we're currently, if you look here, we have aux 1 selected. So if I then go back to my max patch and move node 1, auxiliary 1, we can see on the digital desk that it is moving auxiliary 1. Then if I go to auxiliary 2, we can see that moving. The same with auxiliary 3 and auxiliary 4. So that's how Max MSP works with MIDI to control the auxiliaries. The connection then from the digital desk to the wedges is simply Omni out. With Omni out you can set these to send out for multiple things, such as bus sends or auxiliary sends. Obviously they're selected as aux sends for the minute, so we've got 4 wedges, so there's 4 TRS leads coming out of Omni out, and they are coming to our 4 monitor wedges, which are displayed here. We've then got some microphones set up, 3 mics, 3 SM58s to record the movement of the monitor mixes, and then they're going into the Sound Devices 633 location recorder, just so we can record this and add it to the video. This is the first demonstration test. A 1 kHz sine tone will be playing on an iPhone connected to channel 1 of the Yamaha desk. I will switch on the Metro counter in Max, and this will simulate a musician moving on stage. We will then be able to hear the movement of the sine tone in the wedges. This is the second demonstration test. Dan will be playing his electric guitar connected to the Yamaha desk via DI. I will be moving the musician cursor in Max to follow the real-time movements of Dan. I will do my best to keep the cursor located as accurately as possible. When the TI Max trackers and sensors are utilised at a later date, they will track the musician with an accuracy down to 6 inches.